Hello everyone, welcome to the next video in our series of AI and cybersecurity. Pretty exciting one today. We're going to deep dive into Model Context Protocol. This protocol actually came out last year from Anthropic, and at first there was a lot of skepticism as to why do we need another client-server communication protocol. But I think with the trends that we've seen in terms of the downloads and the popularity of this protocol, it was a much needed paradigm shift in how AI applications talk to external tools, access external resources, and how you can quickly build these apps to be extremely effective. In fact, Anthropic's primary competitor, ChatGPT OpenAI, also approved for MCP to be used within its apps. So let's take a look at what this protocol really is, and we will also see how to build a MCP server today. We will touch upon the security risks of MCP, but from part 2 onwards, we will do a real deep dive into hacking MCP servers. So let's get started. Now imagine a scenario where you have a tool sitting on your desktop, let's say Cursor or Windsurf, or in the example that we will see today, Claude desktop. And you want to download a certain amount of data from an external source, let us say your CRM, HubSpot. You want to see what were the new deals added to the pipeline. And then you want to compose a follow up email to your head of that region and ask them some details on those deals. Or you want to look at deals that were stuck in the pipeline for too long and send out a follow up email. To do this, you would have to integrate your AI application with HubSpot, if that's your CRM, maybe with Slack, maybe with your email client. Now imagine you had 5 or 6 such apps on your desktop and you wanted to integrate with 5 or 10 such systems on the internet. That would result in an 5 into 10 integration nightmare. So you would have to write code that would glue 5 client applications to 10 server side applications. With MCP, that goes away. Every client supports a particular MCP server, and every MCP server provides an interface to a bunch of clients. And so it's like 5 plus 10 integrations, 15 versus 50. Now, this looks a bit confusing, but let's go deeper and it'll become clearer as we go forward. There are certain key terms to understand when it comes to MCP. There are 3 main components in the MCP ecosystem. There is the host, which in this case of this example that we will explore today is my laptop. That's the host machine. There's an MCP client, which again in my case is the Claude desktop. And then there is an MCP server, which provides access to some stuff. What is this stuff? If you see on the screen, MCP servers essentially provide access to 3 capabilities. They provide access to resources, they provide access to tools, and they provide access to prompt templates. Resources are files or data that can be retrieved from the other side, for example, your CRM reports. Tools are things that we can execute, the server can execute on your behalf. And prompts are helpful prompts that the server sends back to the MCP client that you might want to use these kinds of prompts to get more value from the server. So these are the 3 kinds of resources or capabilities that MCP servers provide. The host application, which in this case is Claude Desktop, is the key security gateway that has to enforce a lot of the security controls in terms of validating even the tool description that comes from the server. We don't trust the server. The server should be considered a hostile environment. And so even the tool description could be poisoned, for example. The execution of LLM access is from the client, it's not from the server. So the server triggers LLM requests through the MCP client. So that might also be a route of attack. Any security policies in terms of the files and resources that the MCP client accesses on my host has to be enforced by the host. So that sandboxing has to be done by the host. The server, for example, can request for access to critical files, system files, sensitive files. It is on the host application and the MCP client to control that environment and control that access. Any user in the loop capability has to be enforced by the MCP host. For example, we will look at this concept of LLM sampling, where the server will ask the client to query the LLM that it is connected to. The server is not talking to the LLM directly. The server will request the client to send a request to the LLM. And this request requires a human in the loop uh, interjection before the request gets sent to the LLM. So all of this is designed within the protocol, but the proper implementation and enforcement of it is up to the developers of MCP client software and MCP server software. All right. So let's look at that. The typical communication flows using JSON-RPC 2.0 format. Um, it's interesting to look at this because we might be able to interject some commands or change the ID field which you see on the screen and try and do like a session manipulation attack. So whenever there is a request response kind of communication, there will always be an ID number field in the communication, but there can also be communication sent just by the server. So there can be server side events which don't require an ID. These are one-way communications that don't require a response, and so the RPC message format will not contain an ID field. One example of a server side event could be if the tools on the server side change, the server can send an update across to all of the clients that it's connected to. And this also is where the power of MCP comes in. The tools are not hard coded, the APIs are not hard coded. You can change the tools, you can change the syntax and the format of the tools, and all of this dynamically gets updated by the server to the clients. So a lot of dynamism, fast capability building can happen. Typical client server communication would be the client would ask the server, hey, what tools do you have? The server would send a list of tools back. The client, based on the human request, so the human types in a request saying, I want to do X, the Claude desktop MCP client will query all of the MCP servers attached to the client, bring down the list of tools, extract the list of tools from each of these servers, and send this in a structured format to the LLM that it is connected to, which is obviously Claude, and ask the LLM, hey, for this user request, which tool or tools are best to execute? And then based on that, it will call the MCP server and execute those tools. And the server will execute the tool and send the response back also in JSON RPC format. The client can request to read resources based on the resource list shared by the server. It can ask that I want to read this file or I want to read this URI. The server, as I said, can do, for example, LLM sampling. The server says, hey, I need a little bit of help from an LLM to process this request. So can you pass this information to the LLM and send me the response back? This is where a security issue can occur. So we want to make sure that the MCP client always has a human in the loop for LLM sampling. It can send notifications in case the tools change or the resources change or prompts change, new capabilities get added, and it can update the subscriptions that are available. So this is kind of the flow between a client and a server. There are three key phases in the MCP protocol. There is a initialization phase. For those who are familiar with TCP three-way handshake, MCP is a stateful protocol. It maintains state between the client and the server. Client maintains a 1:1 connection with the server. And so that to maintain that state, there is an initialization sequence and during this time, capabilities are shared and resources and tools and prompts are shared by the server as well. And the certain information that's available from the client is also shared back to the server. For example, what root folder it can access on the local system, etc. And then comes the normal operation called tool, get result, process with LLM, show it to the user. all of that flow happens. And then when the connection has to be shut down, there's a graceful disconnect as well. So this is kind of the three key phases of an MCP operation. As I said, the MCP server essentially exposes three core primitives or capabilities to the MCP client: resources, which is file contents or API pulled data, tools, and prompts. These are three capabilities that the MCP server can send across to the MCP client. And all of this is done using JSON-RPC 2.0. So for example, here is a case of a function that is being called by the MCP client based on the user's request, and we shall now just see this in action shortly. This aspect is also extremely important. How does the client and the server communicate? Now, usually when we listen to the term server, concept is it's something running remotely, but MCP servers can also run on my own system. So again, with the example, we will see my MCP host, my machine, my MCP client, Claude desktop, and my MCP server is all running locally. And when it runs locally, then the communication between the client and the server uses standard input output, stdio. Okay, it's all local. There's no traffic flowing over the network. But obviously, great power also comes from remote MCP servers. We'll see a few examples of that. And this uses the HTTPS. It says HTTP, but obviously we want TLS enforced over here, communication. And also server side events are sent over HTTPS. So that's remote, brings in pretty much all of your web application attacks, and we shall explore some of those. Plus, with MCP, we have a unique set of additional attacks that also come into play. Now, before we delve into the security aspects of MCP, let's take a look at what an MCP code and how does an MCP really execute. So let's go to my Claude desktop running here. There are multiple ways in which, in fact, there are one too many ways in which you can integrate MCP into Claude desktop. I believe they should have given us just one simple way to do it. If you've written your own MCP server, then you can go essentially to Claude desktop configuration and you can add your MCP server here. You can see I have 4 local MCP servers running. This was, if you remember, in one of the earlier videos, we built a RAG. This was my attempt to convert that RAG to an MCP model, same code. This is what we're going to see today: security scanning tools integrated via an MCP layer. In one of my other videos, I've shown you how to build your own vulnerability prioritizer, which also runs as MCP. And then this was an MCP that I built to just update me on a regular basis with the latest security news. So it, collates like 15, 20 high fidelity RSS feeds, and then it creates a security advisory on a daily basis. So this was, we'll explore most of these as we go along in this series. The tool that we are going to look at, and so these get added into my Claude desktop config file. You can locate it in this location. So under your user settings on Windows, for example, under Claude, you'll find this. Similarly on Unix and Mac, you can find the location. And this file is blank to begin with, but you can add these in this format. The other way in which you can add is that if you click over here on this search and tools button, you'll see add connectors. And then you'll see a whole bunch of connectors that are available. This is all MCP. It's not API. So at this moment, I've integrated my Canva with the Claude. I've integrated a few other things. If you dare, you may integrate Gmail and Drive and Calendar and HubSpot. And this was the example I was giving you at the start. So you can then kind of say, hey, extract this from HubSpot, create an email, send it across, right? So there's a whole bunch of this. And then MCP has really proliferated. So you can find a bunch of MCP capabilities published online. For example, one of the MCPs that I just integrated yesterday, which is not in this kind of official list, is These are MCPs that run locally. So I can integrate, for example, my own file system, iMessages, Mac, Windows capabilities, etc. These will all run locally. Um, these are all remote MCP servers. I can also simply add MCP by going into settings, if I remember this correctly. If I add a custom connector, then I can add, for example, just give the URL. If I know the URL, I trust the URL, I can just add from here. And that's what I did. So if we go back here, for example, just yesterday I added Microsoft Learn. So this gives me access to the Microsoft Learn website, which is a phenomenal resource for all things Microsoft. And I intend to now access this as I prepare for any fresh certification on Microsoft Azure or whatever, right? So it will fetch all of that from there. So this is a great capability. So I mean, it kind of just opens up your mind to the amazing things that can be done. Now let's take a look at the MCP code that I built. This MCP code is called security tools. I basically integrated basic ping and map DNS, various tools over here. And I essentially give it a command. And again, the client knows all of this MCP servers listed, right? The RAG one is here. I have additional ones for vulnerability prioritization, for security news, generate a daily newsletter, etc. So it can, based on my command, it will figure out which tools to run those tools. Again, all of this is happening locally, but I've shown you that, for example, I've integrated with these remote servers as well. I have not integrated my Gmail and Drive yet, but the rest is all integrated. And this is essentially what the MCP code looks like. This is what our agentic code looked like. If you may recall, we had defined a bunch of tools, the ping tool, the nmap tool, right? These are the tools that we had defined. And then this was the dangerous execute anything on my shell prompt tool. We don't want to do that. And then essentially we had, this was just about all the code that we needed to get our agentic AI running. Initialize the LLM, give it the list of tools, pull the prompt from LangChain's repository, initialize the agent, and run the agent, right? And that's pretty much it. And then the rest is just the Streamlit code. In this case, this code was calling the LLM, right? Again, with MCP, there is no LLM calling by the MCP itself. Anything that it wants to do with the LLM has to go back to the client, validated by the client, and then it gets sent to the LLM. So in this case, this is asynchronously run. So we import the async IO library. We're going to execute sub-processes on the local system, and then we are going to bring in some of the MCP libraries that we need, right? We initialize the server. This is essentially the function call for give me the list of tools. This will give the list of tools with their description. So this is their JSON-RPC 2.0 format. Every tool has a name, description, in what input schema I expect the input to come from you, from the MCP client. And similarly, for all the other tools, we define what's going to happen. Okay. And then, so that was just for all of the tools. And then this is the actual tool calling code. So here's where we are listing out, hey, based on which tool you've been given, oh, is it ping? Okay, run ping minus n 4 times for this host. So the actual command is given. Error handling is done over here, right? Same with nmap. So there's a whole bunch of else if statements. Again, like I said, nobody is telling it the exact sequence of tools. It's all figured out by the LLM based on the tool list given by the MCP to the MCP client. The MCP server gives it to the MCP client. It's also trying to integrate web app scanning. And then it just runs, right? So this is where I started the server, and in asynchronous format, I actually start reading input, writing to input, initialize it the server name, give it some version number, enable notifications, and that's it. It just runs. So this is the decorator code if I run it locally. But essentially, this is all the MCP magic happening right here. Now let's see this tool in action. So for example, this is the tool run that I did earlier. First, I asked it what security tools do you have access to, and then it lists out all of the security tools, right? So it gives me ping, DNS, who is, nmap, subdomain, port check, etc. And then it describes those tools. Great. Obviously, all of this again is coming from this MCP server. And then I say run these tools in a logical sequence on Transilience.ai, collate the results, and synthesize them into a nice interactive report. So it does that. This icon here, S, means it's running a tool locally. So you can see it's running the DNS enumeration on Transilience.ai. It then does a whois lookup. It does a ping test, does a reverse DNS, does subdomain enumeration, does a quick port scan, does a trace route, does a port scan again on the www subdomain that it found, and produces a report. It's an interesting report. It's some interesting findings here. So finds 2 open ports, 2 subdomains, primary IP address, registrar information, DNS records, network connectivity, subdomains that it discovers, ports that it discovers. Of course, you may say, no, there's more, there's less, etc. We can keep refining the operations over here, but it even does the analysis and says good attack surface minimization, only web services are exposed. Good job to the Transilience team. And this is something that I think we fixed by now. We've added DMARC and DKIM for our email security. And that's about it. I did the same for OpenAI. In this case, I said don't run any port scans. I don't want to run into any legal issues. So I just did what's called passive footprinting. So do a complete footprinting of openai.com. It does that again, very logical sequence. I have not defined the tool list. I have not defined the sequence. I have not said go run this tool in this way. It's all figured that out on its own. Beauty of AI. And it's also written up a pretty cool report. Now, again, you could script this on a Kali Linux box. You could probably script your report writing as well, for sure. But this gives you an idea of how things could go from here. In fact, based on the RAG that I've built, I could say ingest this as a PDF report into my RAG. And the possibilities are endless, right? If I integrate a command line vulnerability scanner, I could then say integrate it with my vulnerability prioritizer, right? So run the scans, give me a prioritized report, and do this, like run it every day in the morning. In the case of OpenAI, it enumerated 9 subdomains, 18 plus services. The domain, interestingly, was registered in 2007 before OpenAI was incorporated. So I guess OpenAI bought this domain from somebody else. The domain was registered in 2007, predating OpenAI's founding in 2015. So OpenAI likely acquired this premium domain later. Domain has both client and server lock level protection locks, etc., etc. So it does a pretty good job, right? Finds out all of this stuff. What it also interestingly does, and my guess is as good as yours, where it got this technology stack insights from. Maybe this is the LLM doing additional stuff on its own. Figures out that they use Google Workspace. They also have some M365. They use Calendly for scheduling. I don't know where it got, but none of my tools should be giving me this. So maybe I ask Claude, where did you get all of this information from? If you know which tool can do this, please put in the comments below. This technology stack, where did that come from? I don't see that in the tool list. Anyway, so yeah, it's a pretty comprehensive scan. And again, like I said, I didn't do any port scanning on this. They also need to enhance their security in some areas. Nothing very significant, right? So pretty cool, right? And again, this is the power of MCP. Just this simple prompt, and everything then gets figured out on its own, right? Now, all of this good stuff comes with security risks. And the best way to familiarize yourself with the protocol and the security aspects as you go deeper is to actually go to modelcontextprotocol.io, where there's extensive documentation on the protocol specs. But more importantly, within, for example, the key parts of this protocol, you will find the security aspects that are there and are not there and are expected to be put in place by the developers. So for example, if we go to the specifications, they have a section on security, trust, and safety. And these are the key principles on which the protocol has been built. Just quick FYI, users must explicitly consent to and understand all data access and operation. So you control what data the MCP servers have access to on the system. Users retain control over data, what is shared, what actions are taken. Implementers should provide clear UIs for reviewing and authorizing activities. So, for example, when we ran that scan, that information does not go back, that report is not going back to the MCP server. The MCP server is running the tool. Yes, it can see the output of the tool, but the final report is visible to the LLM, which was accessed through my Claude desktop, and of course to me as the user. And data privacy, tool safety, all of these aspects. LLM sampling, which I explained earlier, is when the server wants to call the LLM, it has to do so through the MCP client, not directly. And what it requests from the LLM has to be user approved and user signed off. So all of this has to be implemented properly. And as security professionals and auditors and developers, it is the onus is on us to implement these capabilities. This is very important. The reason I'm stressing this, and as we go deeper into this, the responsibilities, if not delivered properly by the developers, will result in massive security issues. And we will see a lot of MCP security issues coming up over the next few. They've already started coming up, more will come. So, consent and authorization flows on the implementation team. Clear documentation of security implications, implement appropriate security controls and data protections, follow security best practices and integrations, consider privacy implications in their feature design. So all of this is on the implementers. And then there is a much more detailed security best practices section, which talks about a whole bunch of security attacks. Confused deputy problem, very interesting. We'll go deeper into this in the next few videos. Token pass-through attacks in OAuth, if you screw up your OAuth implementation. Session hijacking issues, we've been dealing with this since the uh, you know last 2 decades. So similar issues crop up in a different avatar with MCP, following all OAuth 2.0 security best practices. So this will be the fun stuff. We'll go deeper into this as we explore MCP further. So I hope that you got a good idea of what MCP is, what its capabilities are, how it differentiates from APIs, how it makes AI applications so much more powerful because of the dynamism, because of the way in which the tools are declared, the tools are shown, the tool list can change, resources prompts can change, servers can dynamically update the clients using server-side events with that information. How the MCP client, which in this case was Claude Desktop, I just asked it run any footprinting on openai.com. It figured out that the MCP server to use was the security tool server. It figured out what tools were available, in what sequence the tool should have been called. It executed those tools, collated all of that information, sent it to the LLM, built a beautiful report. Again, all of this code I will share in a link to this YouTube video. Please use with care. With great power comes great responsibility. And as we go forward, as I said, there's certain capabilities built into the protocol, and there's a whole bunch of stuff that developers need to be responsible for. Using this information, using the latest data from the protocol specification itself, I have also created an MCP checklist, which also will be linked in the comment section for this video. So these are some examples of vulnerabilities. Who trusts whom? The user trusts the host trusts the user. There is trust between this machine and the Claude desktop, but we do not trust the server. This is an example of why we would not trust the server, because one of the capabilities that the server can send, remember there are three: tools, prompts, resources. The prompt can be modified to have malicious instructions, or the tool description could be modified to have malicious instructions, and these will flow through from the user client to the LLM on the other side. So what we discussed was the 3-tier architecture: the MCP host, my machine, the MCP client, Cursor, Windsurf, Claude Desktop, and the MCP server, which provides me access to three things, three primitives: resources, which are files or API access data, tools, prompts. All of the communications uses JSON RPC. It's bidirectional. It's a stateful protocol. Connection is set up, actions happen, connection is shut down. Security responsibilities are clearly defined between what is built within the protocol itself and a lot of what is on the implementer's shoulders. And so with this, we complete part one. As we go forward, we'll follow the same paradigm. We'll build insecure MCP, we'll break that insecure MCP, and then we'll secure it. I hope you found this first video to MCP security useful. And if you did, please share it with others who might also find it useful, and do like and subscribe. Thank you for watching.